You know,
Yeah.
I just need to get yeah. Yeah, I'm on. Yes, probably pretty easy.
Yeah.
I'm just writing it up to show that.
It's how much you that's everything. I mean, it's also so many places. Don't you start them right? When you're on to make one time. I think they're also easier. It's the lab. When you do the live videos of starting. Yeah. When you submit to the presentation for the secretary, and one guy is, of course, two pictures. And then to check out.
Okay, so I have 9:30, and as usual, before the lab, I'm going to try and help you guys out with the lab as much as makes sense. Like, I can't give you the exact answers, but I can help you get started, right? So we already started with the first encoder, right? And we came up with the equations, or the beginning of the equations, and you guys can finish the rest of them, right? And we also talked about how you can just use the case statement as well. Correct? Are you guys awake? Okay. All right. So this slide was just to write out the rest of the equations, but I think you guys are good with that. So I want to go on to the next part of your lab, which is, again, another encoder, but it has a little bit more logic to it. But one thing that you should note is you can use the implementation from the first part of the lab for this whole part. So you will instantiate your encoder that you make in the first part for the second part. Again, you don't have to, but it is highly recommended that you do. And you will connect a few more signals in between. The first is that now we have an enable signal. So essentially, this is when we are disabled. And when we're disabled, we are just outputting all ones. And this is like when we are enabled, and we should be outputting our normal outputs. And the three inputs that are determining whether we are disabled or enabled are these three signals. So essentially, what you're going to have in terms of your hardware is you'll end up with a mux, because mux is going to select, right? So 0 on top, 1 on bottom. Let's call this enable, right? And this will be your output vector y. And if you're enabled, you're going to take the output from the encoder. Maybe EN is confusing. Let's try and make it large enough where I can write encoder. Right? So normally, but otherwise, it's this vector of ones if it's 0, right? So if you want to make this block, you can make 8-bit multiplexer, or you can use what type of high-level state code? Like behavioral, right? Behavioral. So it doesn't have to be case. It's just a very simple one. It can be if else, right? So you can make one process block. You can If enable, then output is the output of the encoder. If it's not enabled, or you can just put the else, output is just all ones, right? So then the whole thing is, what do we assign our enabled signal to? So if we do enable, when are we enabled? Based on those three, what should this equation be? Yeah, so G1 is 1. So G1, what else needs to be true? Yeah, G2AN is 0, so G2AN not. What else is true? Yep, and G2BN is also 0. If that's the case, we are enabled and we're selecting 1 on the mux. All of the other cases are covered here, right? That's when we're not going to be enabled. We don't care what the input is, and we output once. And the other thing is the input X goes here, right? Is that clear? Okay, so one thing that you might run into is you have this enable signal. If you put it as an output, you won't be able to read from it. But if it's just an internal signal, you'll be able to read from it. So make sure it's just an internal signal, because it's not specified as an output from here anyways, right? So is this, yes. You don't have to change the first part. So for the first part, what you are going to, you'll have it as its own entity, right? And then in this part, just like you said components, say let's call it encoder this time, then you'll put the port map of what your thing looks like, and then you'll say, I'm going to make encoder 1, and I'm going to use this entity, which was this component, and this is what I'm going to connect to it. So underlying in that box is still the data flow architecture that you described, but now you're utilizing it in a structural way in part 2.
So they're in different files.
They're in different files, yes. They don't have to be in different files, but it's useful to have them in different files. You can define multiple entities in the same file, but it's not standard practice. Standard practice is keep things separate. Okay. Any other question? All right. So the next encoder that you're going to make is a priority encoder. So this one is a little bit different in that we can have 0 outputs on any of these inputs, but we only care about the earliest one. So we check the first one first, then the second one. Like if we have a 0 here, we still output that on the first one in this case. So 0 is the one that was 0. But before, if we go back, if we have the 0, if we have 0 as our inputs, we set only this one to be 0. All the rest are ones. So this one is the opposite. We are getting the bit stream and we're decoding it into the binary representation of which one was specified. But the key difference is now we don't care what these leading ones are. Not the leading ones, but the other ones are, okay? So that's why it's a priority, because we check the first one. If the first one is a 0, we don't care what the rest are. Again, if the first one is a 1, then we check the next one. And then the rest we don't care about. If the first 2 are 1s, then we check the third one. We don't care about the rest. Okay, so now that we have that specified, before I go on, is that clear to you guys? You can say no. If the answer is no, we need to keep going over this. Okay, so do you have any specific questions, is what I would ask.
Starting from 0, we start from 7 in binary, go backward.
Yeah, so this is our input, our 8-bit input, right? And let's just call it like Y. So what this table is saying is that if Y at 7 is 0, then my output A should be 0. And I don't care about the rest of the Y inputs. If Y at 7 is 1, then I check, is Y at 6 0? And if that is now the first 0, my output A should be 1. Right? So from here, so this is 0. A is 0. Oh, A is 0. This is the first 0. A is 1. But then to extend this, if Y at 7 is 1 and Y at 6 is 1, then I check Y at 5. And if that is 0, then I output 2 because it's the second. Well, the third, but if we're 0 index, right? Yep.
So it's just like a nested if-then statement.
We will get to the implementation of this, but yes. But is it clear in terms of this part of the table? What is going on? Yes, question? Yeah. Yeah, so I'll talk about those in a bit, but just for the priority encoder part, is it clear? All right. So the first thing I actually want to talk about before talking about GS is this E0. So E0, we can kind of think of as, is my output valid or not? And by the output, it's talking about the A0, the A, right? So essentially, it means that if there is all 1s right here, which is this case, right? That means there was no 0 to find. Then my output is not valid. I just output all ones still, but it just means it's indicating to whatever is reading the outputs that although A is all ones, because E of 0 is 0, it wasn't that Y at 0 was 0. Okay? And the other case is when we have GS over here as 1. So, or actually, no, not GS. The other case is if we have E1 on our inputs, then E0 is just automatically 1. Because E1 basically says I'm disabled. And now E0 is being used instead of my output is valid. It's telling whoever's reading my outputs, hey, I was disabled. I didn't really look at anything. Okay, so that's what it's doing. But we can talk about the implementation of this. And we'll start with E0. And I need this space, so I'm going to erase this. So E0 is fairly simple. I'll call it E0. And we can do it in data flow. First, like I mentioned, if E1 is 1, E0 is 1. Right? You can see E1 is 1. And let me just, right? If E1 is 1, E0 becomes 1. All the other cases, E0 is 0. E0 doesn't depend on it. Okay? The other case that E0 becomes valid, so we're going to OR. I'm using this convention with the plus sign, but in VHDL you would write out OR, right? E0 becomes 1 when there exists a 0 on the input. There is a 0 somewhere, basically. So how would I do that? So Y at 7, not. What else?
Or Y6.
Yeah, or Y at 6, not, or all the way down to Y of 0, not. Right? And that covers E of 0. Because basically we would just need to become 0 if E1 is 0 and there exists no 0. Otherwise it should be 1. Are we good with E0 then? Okay, so the next one that we can cover is GS. So GS, we can again, and one thing that I'm going to recommend, because you might want to use GS, and GS is an output, you can't read from outputs, right? So I'm going to make a GS internal so that I can read from, and then GS, the output, just becomes assigned to GS internal. So now I can read from it internally. That's just a common thing that you might want to do. If you want to read from your outputs, making it an input-output can also work. But if you want to just make sure that it just stays as only output, you can do this, where I have the same signal just copied internally. But when is GS 1? There are two cases, right? Everywhere else, it's 0. The first case, it's again also covered by E1, right? If E1 is 1, GS becomes 1. Everywhere else, E1 is 0 and GS is 0, but now we still need to cover this case. So in terms of our inputs, what do we need to be the case? Yep, so all of them are 1. So this is or what? Yep, y7, y6, all the way to y0. They're all 1. So this covers GS and E0, right? So the next thing that we just need to do is cover our other output A. We see this? And like you mentioned, what's the easy way to implement this? Because we need to check one at a time based on this priority. Yes, so behavioral coding with if statements. So I'm going to make a process block, right? And what is going to go into my sensitivity list? Not A. What does the sensitivity list specify?
Oh, what changes? So the lines.
Yeah, so if anything in my sensitivity list, my output should be reevaluated, right? So it should be my input, which will be y of 7, y at 6, y at 0, right? So this is our process. We have begin, and then we talked about how we're going to use this if statement, right? So which one should I check first?
What part is the sensitivity?
This is the sensitivity list.
Those values.
So it's basically if anything in the sensitivity list changes, then this is reevaluated and changes the outputs. So if you didn't put, say, y of 0 in here and y of 0 changed, it would mean that rather than being purely combinational, this would be latched and it would just stay what its previous result was. Yeah, so y of 7 is what we need to check first. So y at 7. And we're checking if it's 0, right? Then what needs to happen?
A's are up to 0.
Yeah, A should be 0, right? But again, I need to be able to output not just this part, but also this part. So I need to create this kind of intermediate that will be selected later as my output if it's needed. So I'm going A internal. Because if I try and drive my output here, and then I make another process block to do this top part, I'm going to be driving my output from 2 different sources, and that's not possible, right? So I need to make this A internal, and it is simply 0, 0, 0, right? And then what's the next thing in this? Which
If else.
else if?
Oh.
Mm-hmm. And A internal becomes? Mhm.
Would you default to make the 111 result?
So you can do that, but it won't cover this. So you still need this separate process block.
Internal A0, A1, and A2.
Yeah. So you would signal standard logic vector 2 down to 0, A internal, right?
Would you need to square A2, A1, A0 or A1, A0 GS with your boxes?
Like this.
That's why I was confused. I was like,
Okay. Uh-huh.
Are GS and E not handled in the process block?
No, we did them as data flow,
There, okay.
right? They're handled like this. All right, so next I would do y of 5, right? And then all the way down to else if y of 0, and we're checking again that it's 0, and then A internal becomes 1, 1, 1, right? And then you can have else, and basically this means that they're all 0. So again, this just becomes 1, and the reason that we put the else is so that we're purely combinational still. Right? And then you would have down here at the bottom, end if and end process. Right? So that's one process block, and it gives us this part, right? So in order to then output to the rest of this, like we need both parts, we need a multiplexer, right? To choose between this A internal or all ones, right? And to make a multiplexer, we can do, again, what kind of coding? Behavioral. So process. What's it going to depend on? It's GS. GS internal specifically. Because that is going to determine, right, if it's selecting 1 or 0. So again, begin, then if GS internal is what? What should I check first? Either one. Just tell me. Okay, so let's do 0. So if GS internal is 0, then what needs to happen? A becomes what? Yep. Else A becomes what? What does this cover? This one, right? The A internal. It covers the all of these cases. And this one needs to cover these. So it just is 1, 1, 1. Right? So then end if and process. Right? So we have the code to do the priority encoding, select between the priority encoding based on our other signal GS. And then up here, we have the code for GS and E0. So we have all of the code that we need to make this. Right? And we have, I didn't provide like the process, but we have that we do need a process block for this, right? We make this in part 1 and data flow for the enable, which is what we need internally. Yes, question? It's an output, so we don't use it. It's one of the outputs. Oh, and E1? Yeah, E1 is only needed to define GS and E0. Yeah.
Can you go before the test bench? I'm having trouble finding the syntax for them.
I don't have an example of this ready, but if you bring it to me during, say, office hours, or set up an appointment, make a post on Piazza, something like that, I can help with that. But for now, let's do these questions first. Uh-huh. This one is the mux, right? Because we have an if statement and we're selecting two different, we're either selecting A internal or 1, 1, 1. So you would have something very similar to implement this mux too. You have a process and the if statement would be on the enable and the sensitivity list would be the enable, right? And if it's 0, then you output all ones, else you are selecting the, maybe you're calling it Y internal from the output of the encoder. So any other questions on this? We're all good, ready for the lab?
Well, for the enabler,
Mhm.
for the keys. Can you go over that?
To make this enable?
Yeah.
Okay. So I'll switch to laser pointer so I don't mark up the slides anymore. But basically, we're enabled if G1, G2AN, G2BN are 1, 0, 1. Right? And that means that we're going to take the normal output of this encoder. But if we have any of these, then we're going to output all ones.
Okay.
So it's simpler to just say that we're enabled here and we're disabled here. And with this equation, enable is 1 when it's 1, 0, 0. Otherwise, it becomes 0 and you output all ones.
So that mux process block is just like if EN is 0, then push ones, and then if EN is 1, then you
Yeah, you would just do else.
Oh,
yeah.
else, yeah.
Because you want to keep it purely combinational. Any other questions on this? Okay, so we can end early. The one thing that I will ask you to do before we leave, though, is the code for today is, what is it? 544. So do answer the poll, just so that we know that you are here. And if you have your example of your for loop, we can go over it together here. And I also have office hours after this. Oh. Yeah, so if you can pull it up and show it to me here, we can go over it here.